Good day, folks. Welcome to Pride's Mind Academy, where we bring brilliance to every lesson. Now, this video I recorded after now having already recorded now the physical properties video, where now I explained now how each and every independent factor that you might come across, such as chain length, branching, as well as intermolecular forces, affect now the dependent factors such as boiling point, melting, or vapor pressure. Okay. Now, I want us to enhance ourselves by doing at least three exam type of questions, because now I know in class you have probably done many of these questions structured like this, but now you really do crafts, and now when you really do crafts, you get surprised now when you reach exam, then they ask type of craft questions. Okay. But I've already recorded the video, and now it also includes now interpretation of crafts. So now let's be in a position of now understanding how to answer these questions. Okay. Sorry about that. 5.1 says to me, define boiling point. This is a two or nothing definition. Okay. This is a two or nothing definition. This means now it is a definition that it is a must know. A must know definition. If you fail to define this definition as per exam guideline, or as you are supposed to define it, then you get 0. No part marking. We are saying boiling point, it is the temperature at which now the vapor pressure of a substance equals, or vapor pressure of a liquid equals the atmospheric pressure. Okay, yes. It is very important to know the definition so as to interpret graphs, maybe. Yes. Okay. And most of the time, you are asked boiling point. I'm not saying only no boiling point, but it is very important. Now, they say to us, what is the relationship between the strength of intermolecular forces and boiling point? Now, remember we said the stronger the intermolecular forces, the higher the boiling point. The boiling point. Very important. Very, very, very important. Okay. Now we are told that the relationship between the strength, can you see, of intermolecular forces and boiling point is investigated using 4 organic compounds from different homologous series. So now automatically, if they are from different homologous series, we are eliminating independent factor. No chain length. We cannot compare chain length, because chain length, they should be of the same homologous series. No branching. So it means we are only left with one type of independent factor. Independent. This is already the dependent factor. What they are trying to find, okay? The compounds are and their boiling points are. The boiling point is what we are trying to determine. So we refer to as what? A dependent. So now, independent, there will be no chain length, there will be no branching or surface area, if you prefer calling it surface area. But now, the only one that we can talk about, the one that is present, it is now what? Homologous series, or rather, I prefer saying type of intermolecular force. It is the only, okay? It is the only independent factor that I can discuss these compounds with regards to. Remember, if you watch the video under physical properties, I explained each independent factor. When we investigate using this independent factor, the others should be kept constant, should not change. Okay. Yes. So it means now the chain length should be the same. The branching should be the same. If one of these has branch, it means all of them should have branch. Okay. Meaning, if again now the intermolecular force is the one that we are dealing with, now it means the chain length should be the same, the length should be the same, the branching should be the same. Now they are all props. Can you see? Prop. So it is good. It is good. Now, 5.3, they say to us on 5.3, 5.1. 5.3 says refer to the type and strength of intermolecular forces to explain the difference in boiling points between. Okay, now the type you refer to the type, or it either has London forces, dipole, or hydrogen bonding, and now the strength of that particular type you have mentioned. Therefore, it's going to be now between what? A and B. Between A and B, which is propane, and propane has London forces, propan 2 all, propan 2 own, it is an what? Ketone. Dipole, dipole. Dipole. Propan 2 own, it is a ketone. Remember I said, how do you remember this? All hydrocarbons, alkane, alkene, are what? Are London forces. Then alcohol and carboxylic acid are what? Are hydrogen bonds. I come here, hydrogen bond. The rest are what? Are dipole. So I'm going to say, okay, I already see now, or now I can see that propan 2 own has what? Has higher boiling point than propane. Why is that? The examiner wants to know. I'm going to say now, propane or compound A, you can say compound A or propane, it's fine. I'm going to say propane has London forces. Remember, they say the type. First, refer to the type, London forces. On bullet number two, I like to structure it like this. On number 2, okay, let me do this. Propane or rather compound A has sharp. Has London forces. Then I'm going to move to compound B, which is now propan 2 own. Propan 2 own, which is compound B, has dipole forces. Now I'm in a position of saying I'm getting one. Why? Because I have already talked about the type, and now they want what? The strength. Okay, the strength. I'm gonna say the strength. I'm gonna say propan 2 own. Propan 2 own has the strongest intermolecular forces. Do not use IMF. Intermolecular forces than propane. Even if you do not say than propane, but here the mark is here. It has the strongest intermolecular forces, then we are done. Now, they did not say with regards to energy. Okay? Energy, if they wanted also energy, you'll say, therefore, propan 2 only more energy is required to overcome intermolecular forces of propan 2 on than those of what? Okay? Let's look now at 5.3.2. I like it when you answer 5.3.1, then you leave a space, then you answer 5.3.2. It makes it nicer for an examiner to follow now. Okay? We are comparing compounds C and D. C and D, what are you going to say? You're going to say compound C is what? Propan 1 all. You're going to say propan 1 all. Propan 1 all, it is what? It is an alcohol, like we know. Has what? Has one side. Why? Why should I say one side? Because I'm comparing a hydrogen bond to a hydrogen bond, an alcohol to a carboxylic acid. So hence I should say propan 1 all has one side of hydrogen bonding. Then what about propanoic acid? What about propanoic acid? Propanoic acid has now two sides, not sides of hydrogen bonding. And I did explain now in the video that I recorded that between the two, the one that has more sites will be the one that has the strongest intermolecular forces. Therefore, we'll say, therefore, propanoic acid has the strongest intermolecular forces than propan 1 all. Cool. Easy 3 marks, isn't it? Then now they say to you 5.4 is gas, is compound B. Where is compound B? Gas or liquid at room temperature. What is room temperature? Room temperature, you need to know. Room temperature, it is 25 degrees. What is it? If it is boiling at 56 degrees, therefore it means at 25 degrees that it is liquid. Okay? But if they said maybe, okay, if they said at 80 degrees Celsius, if it is boiling at 56, anything above that, it is now gas, okay? But in this case, now it is liquid because it is at room temperature thereof. Now let's look at the type of question again. It says now the relationship between boiling point and number of carbons. Can you see? Between boiling point and number of carbons, carbon atoms in a straight chain molecule of alkanes, carboxylic acid, as well as alcohol is investigated. Curve P, Q, and R are obtained. You are not told whether P, Q, and R are what, okay? Now, the boiling point now is compared, okay, is obtained by now by under different carbons, number of carbons. So now on first carbon, when all of them had one carbon, they had different boiling points. But now on two carbons, they were increasing. Now the conclusion that we can make is that as we increase the number of carbons in the longest chain, or when we increase the long chain, sorry, as we increase the chain length, we are increasing the boiling point. Can you see, as I increase the number of carbons, the boiling point goes higher and higher like that for each of them? Yes. Then now, before looking at the question, I should be in a position of saying I should know which graph represents what. Why? Now I'm saying, okay, I can come here and say, okay, here at the boiling point, it is the lowest. Under one carbon, okay? We are going to look at them when they have one carbon. This curve P has the smallest boiling point, curve Q has the high boiling point, then curve R has the highest boiling point. Now we need to know which one is of alkane, carboxylic acid, as well as alcohol. I'll say, okay, I know alkane has the weakest intermolecular force. Weakest intermolecular force. Therefore, I know if it has the weakest intermolecular force, it should have what? It should have the weakest boiling point. So it means this one, it should be that of the what? Of the alkanes. And I'm going to say, I know carboxylic acid has the strongest. Carboxylic acid has the strongest intermolecular force. Therefore, it should have the highest boiling point. Which one is that? This one. So it means now curve R, I'm in a position of saying, okay, it means now curve R, it is what? Carboxylic acid. Then it means this one here remainder is going to be what? Alcohol. Oh, okay. Is it? Yes. I repeat, I'm saying as the number of carbons increases, if I increase the number of carbons, I am also increasing the what? The boiling point. This is what I see from the graph. Am I in a position of answering the question? Yes. Yes. And it's going to be easy for me to answer the question because I have already interpreted that. Okay. Define boiling point. Can you see now this definition? They like it. It is the temperature at which the vapor pressure of a liquid is equal to the atmospheric pressure. For curve P, write down a conclusion that can be drawn for the above graph. For curve P, what conclusion can be drawn? They did not ask you, is it an alcohol, carboxylic acid, or alkane? They want to know the conclusion that you can draw. What you can draw, the conclusion that you can draw, you can say, okay, on 6.2, you're going to say an increase in number of carbons does what? Increases, cause an increase in the boiling point. Inside the bracket, I'll say not directly proportional. Proportional. Do not say they're directly proportional. Directly proportional, you get 0. I need this, an increase in the number of carbons. First mark increases the boiling point. That's where you get your full marks. Remember, I'm teaching you how to also answer certain questions, okay? Okay. 6.3.1, 6.3.2. Now they say identify the curve P, Q, or R that represents what? Alkanes. Which one? Actually, this one I'll answer it here. Which one represents the alkanes? We already discussed that it is curve P. Can you see that? Curve P. For us analyzing the curve, we are in a position of saying, okay, we just fill up the answers because we already had the answers. Okay. This one I also had. Okay. Now, carboxylic acid, it is what? It is R. We also saw carboxylic acid, it is what? It is R. But now the examiner won't let me just escape like that and guess. The examiner won't let me guess whether it is C, G, what, or what. The examiner will want me to explain to see if I fully understand what I mean. Okay. Now the examiner says, explain the answer in 6.3.2, this one, by referring to the what type of intermolecular forces present in all of them. You have 3 marks for stating this one has what, this one has what, this one is what. The first mark, you say relative strengths of those intermolecular forces. Which one is the strongest? For you saying which one is the strongest, you get a mark. For you saying the one that has the strongest, how much energy is it needed to overcome its intermolecular forces? You get 5 marks. Easy 5 marks. Here, I have a first easy 3 marks. Let me be in a position of saying I'm answering 6.4. The first mark, I'll say alkanes. Alkanes have London forces. I have obtained my first mark. Second mark, carboxylic acid has two sides of hydrogen bond. Why do I need to say 2 sides of hydrogen bond rather than just saying hydrogen bond? Because I also have what alcohol that has what hydrogen bond. So I'm gonna say alcohol yona has 1 side of hydrogen bonding. Oh my goodness. How easy marks are these? How easy marks are these? How easy marks are these? Now I'm gonna compare what the strength, relative strength. I'm gonna say carboxylic acid has the strongest intermolecular force. Right? Then the last one for the fifth mark, I'll say therefore more energy is required to overcome intermolecular forces. Can you see I'm not using IMF, intermolecular forces of carboxylic acid. I'm done. This is me getting what? 5 marks. I'm reasoning for this R and P that I've chosen. Okay. First mark, type, London force. Alkane, London force, 1 mark. Carboxylic acid, not just hydrogen bond, but two sides of hydrogen bond, another mark. Alcohol does not only has hydrogen bond, but it has what? One side of hydrogen bond, another mark. Then you're saying carboxylic acid. Now we are talking about the strength. Has the strongest intermolecular forces. You can say than what and what, it's fine. Another mark. More energy. More energy is required. What more energy is required? But when they said energy needed, more energy needed to do what? To overcome. To overcome. Not to break. Not. If you say break, you're losing that mark. I'm moving on to the last one. I want us to be in a position of analyzing first the graph before being in a position of answering the questions. Why? This helps us now to be in a position of doing what? In a position of uh, just filling up the answers. I'm told that here the vapor pressure versus temperature graph below was obtained for four straight unbranched alkanes. So all of them are alkanes, okay? From P to S, P or PQRS. Now they say from P to S, each compound differs from the previous compound by a CH2. Meaning now, PQRS differ from each other by a CH2. Meaning now, if the first one I had CH like that, the second one I'm going to have what? I'm going to have CH like that. They differ only by the CH2, meaning the fourth one will be something like, can you see? This one differs from this one by this one. Okay? Yes. This is what the examiner means thereof by that statement there. Now they are telling you the vapor pressure I measured in millimeter of mercury. Atmospheric pressure is this. This is very important that we know the atmospheric pressure is equal to how much. Why? Because we know when atmospheric pressure meets the temperature at which the atmospheric pressure equals, when this atmospheric pressure equals the temperature, okay, this equals the vapor pressure, then we are having the boiling point. So this is the atmospheric pressure thereof. Okay, we are told this is the atmospheric pressure. So now let's see which one has this has the longest chain. Okay, which one is has the longest chain length? Now I want to see at this atmospheric pressure which one boils faster. The one that boils faster, remember, or the one that boils at a lower temperature, is the one that has the weakest London forces, meaning it is short. It's a short chain. When I come here, go there. Can you see this one now has a lower boiling point compared to others that we might compare? These ones as compared to this one. So this one tells me that this one has the shortest chain length. This one meaning now as I go there, it has the longest chain length. Okay. Mm-hmm. Now I think we are in a position of answering. Okay. Mm-hmm. Can you see now as the temperature increases, so as the vapor pressure. As the temperature increases, so as the vapor pressure. Okay. Now give a reason why give a reason why alkanes are said to be unsaturated. Because now they have let me say, they have single bonds between what? Their carbon-carbon atoms. Not just they only have single bonds. They have what? Single bonds between their carbon atoms. Define vapor pressure. Vapor pressure, we say it is a pressure exerted by vapor. Can you see? Vapor pressure. A pressure exerted by vapor at equilibrium with its liquid in a closed system. Know your definitions. Know your definitions. They now say use the information in the graph above to answer the following questions. Nothing more. What is the effect of an increase in temperature on vapor pressure? Can you see? I said an increase in temperature. Check here. Let's look at Q. The temperature was 20, the vapor pressure was that. The temperature is now 40, the vapor pressure has increased. Can you see? It causes what? It causes an increase in the vapor pressure thereof. How easy these questions are. Which compound has a boiling point of approximately 68 degrees? I'm gonna come here and say, okay, I want you to see this is 10, 20, 30, 40, 50. I want us to zoom out. Sorry. My math is gone. 50, 60, 70, 90. I want us to zoom out and try to estimate at least now 68. 68 might be something maybe somewhere here. Okay? Let me use my ruler now to be able to assist me. To say, okay, let me minimize my sketch. To say, okay, if I estimate now 70s, sorry, my 68 to be somewhere there. Man, somewhere here maybe ish. Aibo, aibo. What is happening? I wanna hear. Hey. Oh, ay, if I approximate, oh no man. Hi. If I approximate it to be at least somewhere here, okay, my graph has shifted. Ngosiyam. Let me do this. Somewhere there. I'm gonna go straight upwards. Ah. Ish. I don't know why it continues doing this. I'm gonna do this. I'm gonna say I'm gonna go straight upwards with this at this point. Okay, I'm gonna zoom out for you. Hey, when I rule you, I'm bored. Can you see now? At 68 degrees Celsius, which one now? Oh, my goodness, my graph was shifted there. Hey. Let me repeat that. Actually, I wanna see which one reaches this point first. Why? Because I know now, Huri. Yeah, wow. It's a real struggle today. I wanna see, Huri, at this temperature, which one has approximately is boiling. I'm losing focus. Which compound has a boiling point of approximately 68 degrees? Which one is that? I wanna see which one whether it intersects with this one now. If it does at this temperature here, this is the boiling point. This is the boiling point. Remember, the boiling point, it says it is the temperature at which the vapor pressure equals the atmospheric pressure. The atmospheric pressure is 760. Therefore, now at 68, can you see now here it meets the the atmospheric pressure. Therefore, it means now Kev Q boils at that temperature. At 68 degrees, Kev Q is the one that is boiling. I want you to understand that Kev Q is the one that is boiling. Which compound? Oh, they said which compound? Uh, Let me see which compound. So we are going to say compound Q, okay? Compound Q. Where you say compound Q. Okay, I need to bring back. Why am I saying it is going to be compound Q? Give a reason for your answer. I'm going to give a reason for my answer and say it is the temperature. Okay, it's fine. I'll do this. 10.3.2. Q. Why? It is the temperature at which the vapor pressure equals the atmospheric pressure. This is your definition of boiling point. They are asking you why is that. You're going to state the definition of boiling point to say, okay, as per definition, as it says now, it is where the temperature of a vapor, it is the temperature at which the vapor pressure equals the atmospheric pressure. Okay, this is me now being in a position of using now my definition to help me and say, okay, come into play now. I'm being asked a question here, and it requires your prior knowledge. Now let's move on to 10.3.2. Which compound has the longest chain length? Fully explain your answer. We're gonna start and say 10.3.3. I said which one is that? It is the S. It is number S, okay? It is compound S. Let's say compound. Now let us be in a position of reasoning. Why is that? Why is that? Okay? Now, why is that? I'm gonna say, compound, it has compound S, it has the highest boiling point. How do I know that? I know that because now at whatever temperature, let's say it continues there. Can you see now its atmospheric pressure is going to equal the temperature at a very higher temperature. So hence you are saying now it is the one that has the highest boiling point. It has the highest boiling point. And you know that if you have the highest boiling point, it means now it has the strongest intermolecular forces. It has the strongest intermolecular forces. Therefore, more energy is required to overcome its intermolecular force. Molecular forces. How nice. Now they tell you compound P. Compound P has 5 atoms. Okay? Compound P has 5 atoms. Where's compound P? Here is compound P. It has 5 atoms. And you are told that all of them have straight chains, meaning if they have 5 carbons, it can only be like this. Okay, they are not branched. Okay, because you can still have 5 carbons, but you become like this and be this. This is still having 5 carbons, but now you are told that it has what? A straight chain, unbranched. Okay, they are unbranched. So now if it has 5 carbons like that, but they say to us, draw a structural formula of a chain isomer. Chain isomer of P. Now I'm going to come and say, okay, on 10.4.1, 10.4.1, I need to know how P looks. P looks like this. P looks like this with 5 carbons, okay? Now I need to draw a chain isomer. Remember, if you have watched my video of nomenclature, you will know exactly what a chain isomer is. A chain isomer is compounds of the same molecular formula, but different chain length. Meaning now, if this one has, can you see 1, 2, 3, 4, 5? It is C5H12. I need my isomer to have the very same what? To have exactly the same what? What's this? Molecular formula, but now the chain length should differ, meaning I should have a shorter chain length. How can I do that? I can reduce my chain length 2 to 4. But now I need to make one a branch. Where can a branch sit? It cannot sit here. Can you see if it sits there, it is still a straight chain isomer. That has how many carbons? 5 carbons. So it means now I need to put my carbon within and my, like that. This is me now being in a position of saying, okay, I have drawn my chain isomer for that particular compound thereof. This, you can put it here, or this branch, you can put it here. Okay. Let me repeat that. This branch, you can put it here or here. You can just vice versa, it play with it, okay? Wherever you put it, here, or you can put it here and swap them around. It's fine. As long as it is not here or there at the terminal. Okay, yes. Now, they're asking me, how will the vapor pressure of the isomer compare to that of P? Now, how will the vapor pressure of this compare to of that? Now, let me first, if you're not sure, start first by saying which one will have a higher boiling point. You'll say this one will have a higher boiling point. This one will have a lower boiling point. Because why? We know the longer the chain length, the stronger the intermolecular forces. Therefore, the more energy needed to overcome the the intermolecular forces. Therefore, higher boiling point. All right. If I compare this and this one has a high boiling point, and remember is that when we're talking about strength, is that when you have a higher boiling point or melting point, you're gonna have a what? A lower vapor pressure. So this one will have a higher vapor pressure. They are not necessarily inversely proportional, but they are opposite of each other. So I'll come there and be in a position of answering, okay, how will the vapor pressure of the isomer, how will the vapor pressure of this compare to the vapor pressure of P? I'm gonna say the vapor pressure of P will be higher. Okay, the vapor pressure of an isomer will be higher than vapor pressure of P. So it means the answer that I want there, it is higher than. If they asked about the boiling point, I was gonna say it is gonna be lower than. I want to believe you are following. So that's all for us trying to understand how we tackle these questions under physical properties. So yes, let's meet again now on the next series of videos. Okay, thank you very much for joining me. I hope you enjoyed.